One of the first things we need to do is get used to some new notation that you may have seen before or maybe not. So I've got a bunch of it written down here and we'll kind of talk through all of it. So first are a bunch of sets of numbers. N is the natural numbers, and sometimes people include 0 in the natural numbers and sometimes they don't. I'm leaving it out. And then z is the integer, so that includes those natural numbers, but also 0 and negatives. Q is the set of rational numbers, so these are the quotients. They're a over b, where a and b are integers. And this is a typo. B is not 0. That denominator should not be 0. R is real numbers, so that's all the above. It's rationals, it's integers, it's natural numbers. All of those are in there. And also the non-repeating and non-terminating decimals, things like pi and e and the square root of 2 are all in the real numbers. C is the set of complex numbers. So this is the set of all a plus bi, where a and b are rational numbers and I squared is -1. So I is that square root of -1. That's the set of all complex numbers. All right, let's talk about this notation for a second, this sort of set builder notation in that last example. So when I write down this set notation like this, the a plus bi here, I'm telling you what form the numbers take. And then there's a little line, a vertical line, which is sometimes read such that, or so that, or where. So I tell you all the numbers are of the form a plus bi such that, and now I'm going to tell you what the a and the b and the I are. So a and b can be any real number they want, and I squared has to be -1. You may also see that vertical line as a colon. So this could also be a colon instead of a straight vertical line, and that's just a stylistic choice. All right, then down below is some more notation that may pop up. So that backwards E means there exists or there is. The upside down A means for all or for every. The little sort of roundish E means is an element of or is in. And then there's these two subsets. And the only difference here is the or equal to at the bottom, just like you're used to with less than or equal to or less than, right? So the subset or equal to means the two could be the same. If you leave that or equal to out, it means is strictly a subset of or is a proper subset of. So let's write down some examples of using this notation. So for example, I can write R is a subset of C. And I could also, because we know that there are numbers in the complex numbers that are not real, I could also write it as R is strictly a subset of C. The only difference is I cannot write C as a subset or equal to C because of that or equals. Okay. When I write that R is strictly a subset of C, one thing that I'm saying there is there exists a number. Let me change what my notation, it'll make more sense. All right, so it means there exists some number, I'll call it little c, that's an element of big C, but little c is not an element of R. So when I say R is strictly a subset of C, it means there's more in C than there is in R. And so this little sentence after that I just wrote is a way to say that. There is a number C that's an element of the complex numbers, but is not an element of the real numbers. Okay? So I can, with some more, just using that is an element of a little bit more, I can write things like 1/2 is an element of R, and I can write 1/2 is an element of Q, but 1/2 is not an element of Z, for example. And then just one more thing. Let's use some of these sets up here and draw a little Venn diagram of them. So the biggest of these sets of numbers is the set of complex numbers. I did a bad job with that. Okay. And then inside it would be the real numbers. That's a subset of C. Inside the real numbers, the quotients, Q, the rationals, are a subset of R. And then the integers are a subset of the rationals, and the natural numbers are a subset of the integers. That got really ugly fast, sorry about that. So this kind of Venn diagram idea can help you with that too. And we could write it as a big long chain if we wanted to. We could write N as a subset. Make that better. So a subset of Z is a subset of Q is a subset of R is a subset of C. And so you might see things like this in either context, written as a big sentence like that or a little Venn.